Well, welcome back. Let's talk about one last item with our Chapter 4 material, and this is what we call the Poisson probability distribution. In Chapter 4 in this textbook, we're going to be skipping the geometric and hypergeometric distributions, although they are very interesting reading, and I highly recommend going through them just for the academic interest of knowing what those are all about. But one of the things that we need to be able to use with Excel is the Poisson distribution. And let's talk about this one because this is an important one to us as well in our courses. The Poisson distribution is used when we're interested in the number of specified occurrences in a given amount of time or space, rather than a given number of trials. It can be used to calculate the probability of some of the following. For example, a specified number of car accidents during a specific period of time, or a specific number of flaws in a piece of sheet metal, right? So if we have a square foot of sheet metal, we find one or two flaws in that on average, right? That would be something that we could talk about. Other instances, specific number of arrivals at toll booths, supermarkets, and airports. This is a very popular function when it comes to management and operations management. So this is sort of an interesting one for us here. So let's talk about this. It is appropriate to use a Poisson distribution when some of the following conditions are met. If an experiment consists of counting the number of times a certain event occurs within a given unit of time or space, the probability that that event occurs is the same for each unit of time or space. So it's just uniform over that entire time or space. And the number of events that occur in one unit of time or space is independent of the number of that it occurs in other such units. Now, there is a mathematical formula. Here it is. It's the mean number of occurrences per unit time or space raised to the power x, right, for x being the number of occurrences, times the base e. E is a constant, 2.71828, raised to the negative of the mean over x, that exclamation word, that's called a factorial. That means we multiply x by every number less than x. All right. You don't have to know that formula, however, to be able to do this in Microsoft Excel. The way it's going to work is the following. We can find a mean, standard deviation. We're going to use a function called the Poisson distribution, Poisson.dist. This formula doesn't do it very well here. Let's go to Excel. Let's just take a look at what I've got there. So let's say in a recent city, there were 12 murders, right? In a 3-year period, there were 12 murders. Let's use the Poisson distribution to find the following. What is the mean number of murders per year? Well, we said there were 12 murders in a 3-year period. So one way of figuring this out is just simply to take the 12 per 3 years and divide it by 3. And sure enough, okay, so our mean number of murders per year is 4. What's the standard deviation? Well, the standard deviation is always given by taking the square root of the mean. So in this case, if we take the square root of our mean, we get 2, right? That's our standard deviation. So what is the probability for using the formula that in a given year, there are exactly 7 murders? Well, our formula goes like this. Right, we use the formula. I have it right down here. Poisson.dist. X is the number of occurrences. Mu is the mean number per year, and whether we want cumulative, true, or false. We always want false if we only want a single occurrence, and we want true if we just want a cumulative distribution. So let's try this out. For 7, here's what this is going to look like. We're going to take our Poisson, P-O-I-S-S, here it is, Poisson.dist. And so x in this case is 7, the mean number is 4, and we just simply want false in this case because we only want to have exactly 7 occurrences. So that probability, 0.05954. Now, on the other hand, let's say that we're asked to find the probability using a Poisson distribution that x is less than or equal to 7 occurrences. Well, In this case, we're going to type it in for Poisson.dist once again. And we're going to choose 7 as our maximum in this case, 4 as our mean again, and cumulative, well, this time let's go with true. Double click on that if you want, and hit enter, and sure enough, 0.94887. So 0.9489 is our probability that we might enter if we were doing this using our Excel formulas. So that's it. That's what we're going to use with our Poisson distribution, right? Since we can do this using cumulative and single probabilities for each of these things, I wanted to make sure that you had seen those formulas. Don't forget, the assignments due this week is that by Friday, you should have watched this lecture along with completing the lecture 4 form. By Monday of week 4, have completed the chapter 4 web-assigned homework and complete Canvas quiz number 2. That's all I've got for now. Have a great week, everybody.